Parametric equations. Parametric equations in calculus are equations that express a curve or surface using parameters. They are essential in calculus, differential equations, and vector calculus. And also parametric equations are a set of equations that define a curve or surface using one or more parameters. Parametric equations general form is x is equals to ft, y is equals to gt, and z is equals to ht. So I'm going to tell you what's the meaning of the letters we used in general form is. So the x, y, and z are the coordinates, and that is are the parameters, and lastly f, g, and h are the functions of the parameters. The proper way to read this is x is equals to function of t, y is equals to function of t, z is equals to function of t. Parametric equations have types of dimensional, which is the 2-dimensional and 3-dimensional. But in parametric equations can represent curve in higher dimensions, 3D, 4D, and so on. Here are the key formulas for parametric equations in Calculus 1. So I have here an example problem of parametric equations. Find the derivative of parametric equations. X is equals to cosine t, y is equals to sine t. So, solution. First, we're going to derive the x. So, derivative of cosine t, which is negative sine t, and derivative of y, so derivative of sine t is equals to cosine t. Next, the dy dx. So cosine t over the dx, which is the sine t. So the answer, cosine t over negative sine t is negative cotangent t. So that's the final answer. Problem number 2, parametric curve. Find the derivative of the parametric equations. X is equals to 2t squared minus 3t plus 1. Y is equals to t cubed minus 4t minus t. Then, first, we derive the x. So, derivative of 2t squared is equals to 4t, because 2 times 2, 4, that's why 4t, minus 3, derivative of 3t is 3. Next is dy. So, derivative of t cubed is equals to 3t squared minus derivative of 4t, which is 4, and derivative of t is 1. So our dy over dx is equals to 3t squared minus 4 minus 1 over the x, which is 4t minus 3. Problem number 3, spiral. Find the tangent line to the parametric equations. X is equals to t cosine t, y is equals to t sine t. So first, derivative of x, which is cosine t minus t sine t. Derivative of y is equals to sine t plus t cosine t. So our dy over dx is equals to sine t plus t cosine t over cosine t minus sine t. So that's the final answer. Problem number 4. Find the second derivative of x is equals to square root of t plus 2 and y is equals to t squared minus 3. So first we derive the x. So derivative of x is x over 2 square root of t plus 2. Derivative of y is equals to 2t. Then next, dy dx. So cancel 1, and then 2 plus 2t is equals 4t That's why 40, and so our dy dx is 40 square root of t plus 2. Next, second derivative. So we use the product rule. So which is the udv plus vdu. So u is u is 40, then the derivative of v is 1 over 2 square root of t plus 2 plus the v, which is square root of t plus 2 times the derivative of u, which is 4. So next is we're going to use the FOIL method. So 4 times 1, so 4 times 1 is equals to 4 divided by 2, which is 2. That's why 2t over 2 square root of t plus 2. Then plus 4 square root of t plus 2. Problem number 5. Second derivatives of x is equals to 1 plus t squared and y is equals to 4t minus 3. So first, derivative of x. So derivative of x is 2t and derivative of y is equals to 4. So our dy over dx is 4 over 2t. So we need to find the second derivative, so use the quotient rule formula, which is the v du minus u dv over v squared. So 2t times 0 minus 4 times 2 over the v squared, which is 2t raised to the power of 2, or 2t squared. 2 times 0 is equal to 0. 2 times 4 is equal to negative 8 over 4 t squared. But this is not the final answer because we need to simplify. So 4 divided by negative 8 is negative 2. And then 4 divided by 4t squared, which is 1, so automatic t squared. So the final answer is negative 2 over t squared. Problem number 6. Second derivative of x is equals to t cubed plus 7, y is equals to 6t squared minus 1. So derivative of x is 3t squared, then y is equals, derivative of y is 12t. So our dy over dx is 12t over 3t squared. So next, the quotient rule. Second derivative is, so we need to use the quotient rule. So 3t squared times 12 minus 12t times 60 over 3t squared raised to the power of 2. So next, we need to use the FOIL method. So 3t squared minus times 12 is 36t squared minus 12t times 60 is 72t squared over 3t squared raised to the power of 2. So 36t squared minus 72t squared is equals to negative 36t squared over 3 times 3, which is 9. Then add the exponent, so 9t raised to the power of 4. So next is we need to simplify. So 9 divided by negative 36, which is negative 40 squared. 9 divided by 9 is 1. So final answer is negative 40 squared over t raised to the power of 4. That's the final answer of problem 6. So the final answer, the second derivative of the problem number 6 is negative 4t squared minus I over t raised to the power of 4. Problem number 8. Find the tangent line to the parametric equations. X is equal to t squared minus 2t y is equals to 3t squared plus t. So first, we're going to derivative of x. So the derivative of x is 2t minus 2. Then derivative of y. So derivative of y is equals to 60 plus 1. So next, the dy over dx, our dy is 60 plus t over 2t minus 2. So proceed to the last problem. We have given parametric equations. X is equals to ln cos 3t squared plus 1. Y is equal to sec 3t squared plus 1. So first, derivative sa first of all, we need to differentiate the x with respect to t and y with respect to t. So dx over dt, negative 60 sine 3t squared plus 1 over cos 3t squared plus 1 kay. So, dx over dt. So, kibaw naman tano kung ang formula sa ln, u prime over u. So, derivative sa cos is negative sine, and then negative derivative of 3t squared is 60. So, 60, then derivative sa 1, 0 kay kanang constant number. So, ang derivative sa u, 60 sine 3t squared plus 1 over the u cos 3t squared plus 1. So, ang sine over cos kay tan. So, negative 60 tan 3t squared plus 1. So, mo ni ang derivative sa x. Sunod, ang y. Mara Japon to gamitan og kana gatong u prime over u. Derivative sa, so first sec 3t squared plus 1 tan, ang gamitan ni kay sec u tan u. So sec 3t squared plus 1, then tan 3t squared plus 1, and derivative sa 3t squared is 60 over 6 over t ay 6 over negative 60 tan plus times 3t squared plus 1. So cancel. So ang nabilin negative sec 3t squared plus 1. So second derivative, negative sec times 3t squared plus 1 tan times 3t squared plus 1 times 60. So, negative sec times 60 is equals to negative 60 sec, then 3t squared plus 1 tan 3t squared plus 1. So, this is the final answer.